Hi students, now we are going to discuss about some named reactions in organic halogen compounds, that is haloalkanes and haloarenes. So the one named reaction is Darson's halogenation. Darson's halogenation, it is a method of preparation of haloalkanes. Haloalkanes can be prepared from alcohol. Okay, so primary alcohol like ethanol, when treated with thionyl chloride or sulfonyl chloride SOCl2 to form haloalkane, chloroethane. So here we have taken ethyl alcohol, so it is giving chloroethane. The OH is substituted by Cl. So SO2 is evolved and HCl is evolved. It is a nucleophilic substitution reaction. And then Finkelstein reaction. Here lower haloalkanes can be converted to higher haloalkanes. What do you mean by lower and higher? So in the halogens you have fluorine, chlorine, bromine and iodine. So okay, in that group. So bromine is a lower alkane than lower halogen than when compared to iodine. Chlorine is also a lower halogen when compared to bromine and iodine, and so on. So this reaction we are considering bromoethane, where it is treated with concentrated sodium iodide in acetone, and when it is heated it forms CH3CH2I iodoethane. Here you can see that the bromine, the lower halogen, is substituted by the higher halogen iodine from sodium iodide. So the byproduct will be obviously NaBr. So the byproduct is NaBr. So this reaction is called Finkelstein reaction. Again it is nucleophilic substitution reaction. Bromide is substituted by iodide. So it is nucleophilic substitution reaction. And the next one is Hunsdijker reaction. So it is again a method of preparation of haloalkane, okay, from silver carboxylates. Silver carboxylate in the sense when you consider CH3, CH2, CO, OH, it is propionic acid. Instead of H you have silver, so it is silver propionate. When it is treated with bromine, in the presence of carbon tetrachloride, it is reflexed in the sense boiled and it is attached to a condenser. When a boiling flask is attached to a condenser, so that the vapors which are evolved condenses back and it is continuously boiled. So here you can see that the COO group is evolved as carbon dioxide. Just see, evolved as carbon dioxide. CH3CH2 will attach to one of the bromine atom to form bromoalkane, bromoethane, and silver bromide as the byproduct. So you are taking silver propionate, but you are only getting bromoethane, not bromopropane. So you should be able to appreciate that. Okay, this reaction is Hunsdijker reaction. And then comes Raschig process. Raschig process is a very important process. It is the process of commercial production of chlorobenzene, so which is an aromatic halogen compound, that is haloarene. Okay, here the benzene vapors mixed with air and hydrogen chloride are passed through heated cupric chloride. Chlorobenzene is produced. The byproduct will be water. So look at the equation: benzene with air, hydrogen chloride, CuCl2, cupric chloride, heated at 525 Kelvin, you get chlorobenzene plus water. Okay, this reaction is called Raschig process, the commercial production of chlorobenzene. Then comes Dow's process. It's a very important process. Here you get phenol from chlorobenzene. It is a property of haloarene. Okay, chlorobenzene, when treated with, you can also put that benzene ring and attach a chlorine atom is attached. That is also chlorobenzene. So when treated with sodium hydroxide at 350 degrees Celsius, 300 atmosphere pressure, you get this Cl is substituted by OH. Again it is nucleophilic substitution. The byproduct will be obviously NaCl. So you get phenol, C6H5OH, and NaCl is the byproduct. This comes under the preparation of phenol. Okay, it is a property of haloarene. It is a method of preparation of phenol. Then comes Woods-Fittig reaction. You have come across Woods reaction in alkanes, hydrocarbons. So in the Woods reaction, two haloalkane, okay, it is treated with Woods reagent sodium. The two haloalkanes. See, for example, this is C2H5Cl. Imagine C2H5Cl, C2H5Cl, 2Na. You get C2H5 bond C2H5. That is butane, and the byproduct is NaCl. Instead of haloalkane, here haloarene is taken. When haloalkanes are taken and sodium is the Woods reagent, the reaction is Woods reaction. Here one is haloalkane, the other is haloarene. Haloarene in the sense chlorobenzene. Here this is chloroethane. So this reaction is Woods-Fittig reaction. Same Woods reagent is used. Here C6H5, C2H5. They will combine, join to form ethyl benzene. C6H5, C2H5. What is left here? Cl, and here also Cl, 2Na. With the sodium it combines to form NaCl as the byproduct. So I told you that Woods reaction is two alkyl halides, that is haloalkanes, combined with sodium, react with sodium in ether medium. When it is heated, sodium dissolved in ether is Woods reagent. When it is heated, you get ethyl benzene here in this case. When it is C2H5, you get butane. That is Woods reaction. This is Woods-Fittig. When both are haloarenes, both are haloalkanes, Woods reaction. One is haloalkane, one is haloarene, Woods-Fittig reaction. Both are haloarenes, it is Fittig reaction. So Fittig reaction is C6H5Cl with the sodium Woods reagent dissolved in ether, another C6H5Cl which is chlorobenzene to form C6H5 bond C6H5. This compound is called biphenyl group. C6H5 is one phenyl group. So two phenyl groups linked to each other, so it is called biphenyl group. The byproduct is NaCl. So it will also asked like this, how biphenyl is prepared. So for that also you must be able to answer. Okay, so that's all about a few named reactions. We have discussed about Darson's halogenation, Finkelstein reaction, Hunstaker reaction, and then Raschig process and Dow's process, Woods-Fittig reaction, Fittig reaction. Also we discussed about Woods reaction. Okay, so you may get any one of this named reaction in your exam. So all the best students, prepare well for your exams.